Hi everyone, welcome back to GeomaCan. I'm Robbie, your host for this episode, and we are back with part 2 of our talk with Geoffrey Jacobs. Last time we talked about how Geoffrey got involved in 3D laser scanning and the early days of Sierra technology. Today we are picking up where we left off. We will be talking about the turning point that made 3D laser scanning a big deal, the competitor of Sierra, their marketing strategy, and some early application they found for this technology. We will also take a look at the future of this technology. Jeffrey, thank you again for being here.
My pleasure. My pleasure. A
So
lot
just
is a lot to talk about.
yes, just before continuing our discussion, in the first part, we talked about Ben Sira specification, and you specified that it was required to have a precision of 1 millimeter to 100 meter, which I found too much for the first time. So I have been searching in your articles, and I found that it was more like 6 millimeters at 50 meter, which I
Right.
found more achievable. So I just want to confirm from you which one is uh, the correct one, or the which one is the good. And
Okay.
just to remind our audience, the specification of Ben Kesura, the co-founder of Sierra startup, to develop her to develop the laser scanner were to have a portable time of flight laser scanner that can scan 1000 points per second, and it should be safe, which without requiring a specific special glasses, and also to have a specific precision.
Okay. So on this topic, the original, the formal specification of the first scanner, the Cyrex 2400, was 6 millimeter positional accuracy at a range of 50 meters. In the very beginning, when this was sort of in the earliest idea phase, and Ben Kassira had sort of, I'll call it, a wish list of what he would really wish for if it was feasible. He actually, and I learned this from the chief technology officer at the time, Dr. Jerry Dimsdale, and I learned it after I wrote the articles about it. Was he originally Ben's wish list was for 1 millimeter accuracy at a range of 100 meters. And one of the as Jerry got into the development of it, it became obvious that that was not feasible, right? And so that target changed to 6 millimeter accuracy at 50 meters range during the course of the development project. And that's what, in fact, the scanner was able to achieve. And that was actually a very, very big achievement at the time.
Okay, I think it is more clear about the difference. So, for you, were there any significant turning points or breakthroughs that shaped the trajectory of 3D laser scanning development, moving it from a niche technology to widespread adoption across various industries? I think I know it is a very big question. So, what do
Yeah,
you think?
it's a fun one, because I was involved in so much of it. There were some tech breakthroughs and advances that were general ones, but there were many breakthroughs and advances that were very industry specific, right? That helped specific applications. And as a startup company, when in the big picture, these hardware technologies breakthroughs from one generation of technology to the next, they can take a long time. They can take multiple years, right? So you join a startup company, it's like, okay, here's our scanner, here's our software. and we need to get on with things and see if we can sell and provide and have the products provide benefits to the users, right? So from a product development standpoint in the early days, again, we couldn't do much with the hardware itself. So we focused a lot on, from a development standpoint, on software advances for specific industries. There were, like, it was like if we could make advances on the software side, which we could do, sometimes we could, add code within a day or two to add an important feature. That was sort of our general strategy. And we could see early on that the technology could provide benefits in a lot of different industries. Okay. Um, the main target ones were what is referred to the AEC world, architecture, engineering, and construction. And the three big target markets there would be industrial plant industry, civil infrastructure industry, and buildings. Okay, just houses and commercial buildings, right? We could also see potential in heritage documentation, university research, capturing forensic scenes, even in making movies and commercials. And over time, we saw there were opportunities in video games and virtual travel. And it reminds me, I got involved before I joined Syra. I worked for Trimble. In the early days of Trimble, it was pretty much the same thing. You could see with GPS, right? There was a lot of potential applications for GPS, right? And when, especially as a small company, you look at all these applications, you get very excited, right? But you have a very finite, especially as a small company, you have very finite resources. So you have to really choose which ones to focus on, right? Because you can't do them all. You can't even do them all when you're a big company. But when you're a small company, you have to really focus, right? So the question we had was, well, which ones do we focus on first? Where can we make the most advances first, right? And in this particular case, the very first industry we really focused on and why it was developed in the first place was the industrial plant market. Okay. And I think it's helpful to look at these markets over time because there are big advances in each one over time, right? As I go through them and think about them, I think it's helpful to understand, why was this a big deal? Why was that advance a big deal? Because without understanding why, it's hard to appreciate just how far 3D scanning has come, and how amazing the progress has been. So again, start with the industrial plant industry, which was that's what Syra developed its scanner and software for. And it was specifically for safely and efficiently creating accurate as-builts that are needed for good retrofit, revamp design, and smooth construction on those projects. Okay. So on the office workflow, the original office workflow, there was only one workflow. Okay. That was it. You scanned, and then the only way you could provide an as-built for an engineering company for a revamp project was to process the scan data into a model, a 3D model, right? In Syra's case, the software converted into basic 3D geometric models like cylinders, which were for pipes, planes for walls, etc. Okay, so you converted all that data into a 3D model, as-built model, and then exported that model by way of a DGN format into 3D plant design software. And there, a piping designer could do their retrofit, their pipe routing, and their design work. Okay, that was it. That was the only workflow. You could also go in and do single measurements if you wanted to, but for an as-built, that was the process. Well, it turned out that was a very painfully time-consuming process. Trying to convert all those, scan points into models and then export it was very time-consuming. And it was also very difficult to create a surface model, geometric surface model of everything that you scanned. So so people, what the process was, users would just scan big piping and big stuff and not worry about the small stuff. Okay. That's what they did. So between the limitations of the scanner itself, which had a limited field of view, 40 by 40, and scanning 800 to 1,000 points a second, it was heavy to lug around. The technology actually wound up only being used on projects there where it was almost impossible to do as-builts manually. Okay. And there just weren't that many of those projects, right? So the first big workflow breakthrough was we had requests from a couple of customers that said, you can export the models out. Can you guys bring in a CAD model into your software? We had this request come in from a couple of different customers. And it was kind of surprising. Why do you want to do that? Well, it turns out that if you could import a model, let's say a proposed design model into the point cloud, there were a couple of big benefits. Okay. One was you didn't have to model everything that was in the point cloud. You could actually do design work in the Cyrus software. You could create pipes and route them through the scan data without having to model all the scan data. So that was a huge time saving. The other big benefit was you didn't have to selectively model anything. You brought a proposed design model into the scans, and the scan captured everything, right? So you could literally do a clash detection because that was added into CGP. You could literally do these clash detections right in the CGP software, and that was a big benefit because you knew exactly what was there, right? It was even more realistic because let's say there was a long pipe run and you modeled a long pipe, but that pipe might have had a little bow in it, right? That bow, if you modeled the pipe as a straight cylinder, then wasn't really exactly what was out there, right? But when you could work directly around the scan points, if there was a bow in the pipe, it would show in the scan data, right? So it was actually a more true and realistic representation of an as-built. So that was a big breakthrough in terms of time in the office, usefulness of the data. That was a big benefit, right? The next big breakthrough that happened there was that was great that you could do that in the CGP software, this 3D, point cloud software, but not everybody felt comfortable in that interface. It was kind of hard software that was hard to learn and hard to use. What designers really want to do was to work directly within their own CAD software, right? But CAD software at that time, there was no way CAD could handle the size of point clouds. If you tried to import the point cloud data into the CAD software would just crash, right? So Cyra developed these plugins, point cloud plugins for the popular software. The first ones were for Bentley MicroStation software and for AutoCAD software. And these plugins were called CloudWorks, right? And the big benefit there was that you had capability now within your CAD design application, where the designers were familiar. They know what they were doing in their CAD application. That they could work with point cloud data directly in their CAD application, right? And that was a big breakthrough from a friendliness, a user friendliness of the software, right? They didn't have to learn CGP or Cyclone or anything like that. They could just work in their CAD software that they work through all the time. And what they would do is they would bring up the point cloud in CAD, and then they would just do their CAD design tools and route pipe directly around the points, right? And that became the go-to workflow. Okay, that was a big breakthrough. And all this was happening again while the hardware iterations take years, at least 2 or 3 years between one generation and the next, but you can do software advances pretty fast. So that was a big deal. And in fact, that CAD application, that plugin, was such a big breakthrough that Syra actually developed a business contract with Bentley, whereby Bentley actually sold the software. So they sold the CloudWorks for MicroStation plugin because, well, it's only their customers who were using it, right? And then Syra got a portion of the revenue when they made the sales. So Bentley was the first CAD vendor to really have point cloud capability they offered to their customers, right?
And which year did
That
Sierra join it?
was, yeah, that's a good question. It was for the early 2000s.
So
It was the early 2000s, yeah.
did Sierra join the Trimble finally or not?
No, that's a very good question. I'm going to come into that a little bit, but yeah, by that time, Syra had been acquired by Leica. Okay, Leica invested in Syra in late 2000 and fully acquired the company in early 2001. And so Ben Cassira was no longer the head of the company. Dr. Erwin Fry was our CEO. And I sat in those meetings with Erwin and Greg Bentley. And we wound up having a great business relationship with Bentley at that time. So that was probably in the early 2000s. I don't remember the exact, but it was right around then. And that was a big deal. It was also, for the technology to have a CAD vendor like Bentley, it added a lot of credibility to the technology globally in terms of adoption, right? It's like, oh, okay, Bentley's doing this, it must be good, right? There was an even bigger breakthrough that really caused the scanning capabilities to explode in the plant industry. It was huge, and that was an application called TrueView. Okay, and that was introduced in 2006. And I'll give you some background on this one. As a vendor, and people that are familiar with laser scanning, they go, "Wow, this laser scanning data is very rich data," right? But what we were seeing was there was still these barriers to adopt it, people using it and adopting it. And it was all around the fact that it was 3D. You had to be skilled in 3D to be able to use it, right? Whether you're working in Cyclone or whether you're working in AutoCAD or Bentley's software, you still had to work this in 3D. And at that time, 3D was not as common as it is today, right? Video gaming has made 3D ubiquitous, right? But back then, there was still a lot of people who felt uncomfortable with it. Okay. But we knew it was very rich data, and we thought people are just not taking enough advantage of it. We need an application, a software that anybody could use, where you didn't have to be a 3D expert, you didn't have to be a CAD expert, just anybody could use it, right? And that's led to the development of TrueView. And TrueView, if you're not familiar with it, and there's lots of variants on it today, was exactly that. It was a way for anybody, and it was totally intuitive. You didn't need heavy duty training. It was just intuitive. And it's a panoramic view of a scan, right? Yeah, it puts the reader's eyes right where the scanner was when it captured the scene in a panoramic 3D viewer, right? But it's not just a viewer. You can zoom in, you can pan around, you can take measurements between objects that you see in that view, right? And you can also make annotations on a view and say, and you can share that in annotation with others. And it was all web enabled, right? So this enabled instant wide sharing, right? Overnight, it was a huge success, right? I'll give you an example of it. We had a lot of our early plant users were the offshore oil industry. Right? Somebody need to do a modification to an offshore oil rig. And we had one user that was providing services out of Norway for the North Sea area. And that engineering company at one point had 7 licenses of our between Cyclone and Cloudworks. Okay, they had 7 licenses. We introduced TrueView, and it just it went from 7 licenses to literally within a couple of months there were over 200 users in that company that were using TrueViews for their for their design work. And then it turns out the operations staff liked it because they could just walk around. The way you used it was it was a plan view of where the locations of the scanners were, and you would click on a location in the plan view. It would open up the view, and you had this panoramic view. You could do measurements, you could zoom in, you can make annotations and share it around. And so the engineers and designers and then operations staff, it was basically the precursor to digital twins, right? It allowed virtual visits, and especially to offshore platforms, right? That was a big deal. You didn't have to take a helicopter out there to make a measurement. You could just do it from your office, right? And see exactly what was there. So that was a huge boost in adoption of the technology in general. Okay.
I think the review of Leica still exists until now.
Oh yeah,
Yes,
it
exists.
Right.
And
In fact, all of the major scanner vendors and even I think the CAD vendors, they all have the capability to do that now, right?
yeah,
And if you've ever seen there's an application by Matterport that if you go looking online for a home to buy, right? They'll have an application called the 3D walkthrough, right?
and also teleportation.
Yeah, and it's exactly that's what it is. You can move from one spot where they set up their camera scanner to the next spot, to the next spot, to the next spot, and that's what TrueView innovated back in 2006, right? So that capability to just hop around the site and view it and measure, and in TrueView's case, make annotations was a big deal, right?
And I think in 2006, the Xerox 2400,
That was no longer.
Yeah,
Yeah, it was no longer. In fact, that was another huge breakthrough on the hardware side, was that there was, especially for the industrial plant market, was the introduction of these ultra high speed phase-based scanners that would be commercially successful. They didn't have there was another one introduced in 1998 in the beginning, but there were severe eye safety constraints with it. The one that was introduced by Zoller and Froelich, Z plus F, based in Germany. And they introduced, it was called the Z&F Imager 5003. They introduced that in 2002. Okay. And it was a short range, indoor friendly, very high speed laser scanner. And that caught on very rapidly in the industrial plant market, because it turns out most industrial plants, you don't need the long range. They're packed with a lot of piping and equipment, and you have to move the scanner around a lot. And these were very fast scanners, and they were accurate enough at close range to meet the requirements of plant designers. Shortly after Z&F introduced theirs, there was another company in Germany that introduced a variation of it. It's called company was called IQ Sun, IQ Evolution. And that company was acquired by Faro in 2005. And so those two scanners were basically heavily used in industrial applications. In fact, that the ZNF scanner was so popular in the industrial plant world, and that space was so important to Leica, that Leica and ZNF reached an agreement, just like Leica had reached an agreement with Bentley, where Leica just put a Leica label on the scanner, and Leica also sold that same scanner. It was called call it HDS. I got the wrong name there, but
I think it is the HDS 2500. No,
that was right after the 2400. I'll think in a second, but Leica sold that same exact scanner, and a lot of customers preferred dealing with Leica as a big global survey company instead of the ZNF, which was a small sort of a regional company. But it was a very big deal. It was heavily used in the industrial market. Another aspect of that was that while those scanners were very popular, they produced enormous point cloud files. And the software wasn't really, the software that had been available wasn't really well suited to that. So there was developments both by ZNF and by Leica, and there was another little company called Bitwise that were made advances in software to be able to actually work with files of those sizes. Okay. And that was very important as well. In addition to the technology developments, there were also some commercial successes that were big breakthroughs in the plant market. Okay, one of the biggest early ones, and it used the original Cyrex 2400 scanner, was done by one of Cyrus Beta's users. It was a company called Raytheon Engineers and Constructors, a big plant engineering design construction company. It's now part of URS. URS is a big, huge global engineering design construction company. Raytheon used it on a big plant retrofit project for a company in Michigan, and it was Detroit Edison. The project was, at the time, $250 million project. And the senior project manager for that project went on record and said that using that scanner and the software, again, this was all the original process of creating a model, exporting it, it saved the company over $10 million. And it also saved many months of schedule, okay, for that retrofit project. So that was to have a big engineering company that had used it on a big retrofit project and have the project manager himself come out and publicly say that it saved us at least $10 million was a huge deal. Okay, we publicized that a lot. In fact, the company won an award, an innovation award in the construction industry for that project. There was another early project that was also a big breakthrough. And that was also done by a beta customer of Cyrus, Chevron. Chevron used scanning for a retrofit on an offshore oil platform in the Gulf of Mexico. And on that project, they saved some money versus having done the traditionally, which they had already done as-builts manually, actually, on the project, and they felt nervous about it because these retrofit projects were notorious for not going very well. And they changed their mind, decided to scan the platform and use that as a basis for design. It turned out they modified their design based on using scanning. And that project, they saved a lot of money on the project for the retrofit itself. But the big win there was they had planned to shut down that platform. And that platform was actually a collection platform from a bunch of other platforms. They had planned to shut down that platform for a few days. This retrofit went so smoothly that they were actually able to get the platform back and operational much sooner than they had planned. So for Chevron, that worked out to many millions of dollars in additional revenue that they were able to get from that from that platform. So this aspect of reducing downtime, because a lot of times if you're doing a retrofit construction project, you have to shut the facility down, right? And being able to get that facility back up a lot sooner was a huge benefit to the owner, to the owner operator of that facility, whether it's an offshore oil platform or a refinery or a nuclear power plant. Getting things back up and running sooner was a huge benefit, and that was also publicized by the Chevron project manager for that retrofit project. Talked about it at conferences, and I'll get into that a little bit more later. There was another big early success that was a breakthrough. The technology started to be used for these offshore platforms early on, and Petrobras in Brazil said, "This is great. Okay, we need to do this on a lot of our platforms." And we had a service provider early on, I mean, really early on, that had over a dozen laser scanners doing nothing but scanning offshore platforms, okay, for Petrobras. And again, that was also widely published. So when you started to have these commercial successes of the technology being used by big organizations, well-known big companies on big projects, and started to be adopted, that attracted a lot of attention from everybody in the industry, right? And those project breakthroughs were breakthroughs for the technology within the industry. And then finally, in that whole space, especially once these high-speed scanners came out, a couple of the big automotive manufacturers started to do a lot of scanning, because in the automobile industry, they change the models every year, right? So they're constantly revamping their production lines, right? And they're doing retrofit work on their production lines, right? So BMW started to scan a lot of their facilities, and then General Motors started to scan a lot of their facilities. And in fact, the application of CloudWorks for AutoCAD was developed for General Motors, because their design software was all based on AutoCAD, right? So you had on the oil, and gas side, you had Chevron power plants, you had this Raytheon engineers and constructors, was Petrobras and oil and gas, and then in automotive, you had BMW and General Motors. So those are big names that were starting to use the technology very early on, and that really accelerated adoption for the technology in the plant market. The next big market that came along and that we focused on was civil infrastructure. Okay, that's a common domain for surveyors, right? And there were a lot of things that happened in that space that accelerated adoption over time. Biggest one we talked about earlier was that Leica Geosystems acquired CIRA. Okay. Before that, for the civil infrastructure market, there was CIRA. There was a company in Austria called Regal. There was a small company in France called Mency. That was a offspin of EDF, Electricité de France. And then there was a little startup in Pittsburgh called K2T that became a service provider. But these were four little startups, or Regal wasn't really a startup, but these were four companies that were not necessarily the common vendors in the survey market, right? Surveys didn't know them. They just didn't know. But once Leica Geosystems bought CIRA, then you had a big survey company that it got into this technology, right? And then the surveyors all perked up their interest, right? Especially Leica customers. They said, "Oh, this okay, this," and that was a huge factor in the adoption of the technology. Leica Geosystems is offering this. That's a big deal, right? And of course, over time, Trimble wound up offering it, and Topcon wound up offering it as well. And they all have good offerings today. But once those big vendors in the survey industry got involved in scanning and started to offer it, That was a huge factor in accelerating and breakthrough for the technology in the civil infrastructure market. There were a couple of applications in particular were early breakthroughs, where even the earliest scanners, were beneficial. One was capturing vertical rock faces that are often like near highways. You don't want to make sure the rocks don't fall down, right? And it was used for that. But that was sort of a niche market. It wasn't a big common application. The one application that really started to break the market open for scanning and civil infrastructure was surveying busy roadways. Okay, turned out with a scanner, you could capture the geometry of a roadway. Let's say we wanted to do a modification to the roadway, expand the number of lanes or whatever. You could capture that geometry from off the side of the road. Right? You didn't have to close down a lane and have surveyors walk out on the road to survey the surface of the roadway, right? And it turned out when we got into this, we started looking at it. It turns out that the cost of securing, let's say, the highway or police, services to shut down a lane was about the same cost as doing the survey itself, right? So if you could avoid that cost and that inconvenience to the public of having to shut down a lane on a very busy roadway, and you could still survey it off the side of the road, that turned out to be a good application for scanning, right? And there was one of the early customers used the very first Cyrex 2400 to put it up on a boom and scanned a very, very busy roadway that was in Silicon Valley, a big commuter section of the roadway, a couple of miles. They used it for that project, and that project was featured on the front cover of one of the of a major survey magazine. Okay, so he was like, "Oh, scanning can be used for this, right?" So that was a big deal to get on the cover of a magazine to showcase this application of scanning busy roads. Another big breakthrough there was, remember I said for industrial plant. Turned out in industrial plant, the main 3D plant design software was by Intergraph. It was called PDS. PDS was based on the architecture for it was based on MicroStation, right? So, well, MicroStation wasn't just used as the basis for the MicroStation is a very popular application for civil infrastructure projects, right? All the Bentley applications based on MicroStation. So when Cyra came out with CloudWorks for MicroStation and Bentley offered it, that was a big plus. Be able to use point cloud data for civil infrastructure projects right in MicroStation, right in your MicroStation applications, right? That was a big plus. On the hardware side, we monitored. I was, especially me, it was kind of my main job, as I was always monitoring, well, how are our customers doing with this new technology, right? A lot of them were struggling in the early days, but the civil survey side really kind of had a breakthrough when the HDS 3000 came out, and that was the first scanner that had a full 360-degree field of view, as well as being able to scan overhead, right? And it turned out that scanner was very beneficial for being able to do detailed topographic and site surveys, right? And also good for capturing underneath bridges, right? Bridges turned out to be a big application as well early on. And the work practice that customers used then, it was still that scanner can only scan like a couple thousand points a second, maybe 2,000 points a second, right? It's slow. So a full 360-degree scan used to take literally 45 minutes. Okay, 45 minutes to do a scan. So but the way it was wound up being used successfully was that customers would take the scanner to a site And when they got to the site, they'd put the scanner in good location and they just started, they would say, we're going to start it spinning, right? And they would just let it scan, right? And you didn't have to stand there and, and watch it. Maybe if you were worried about getting stolen, but otherwise you just let it scan. And then the surveyor, while the scanner's picking up everything it can see, there's certain points, especially low points or points that are hidden from the scanner. The surveyor would take out their GPS unit and go and get control points, and they would take their toll station or their GPS unit and capture the points the low points that the scanner couldn't see, right? So the scanner's collecting the bulk of what's needed, all the surface detail, and the surveyor is walking around capturing all the points that the scanner couldn't see. And they use that, so you had one person with essentially truly a robotic scanning instrument. It's just scanning by itself, right? And when they started to do that, they found that it was very economical to use that process for doing site and topographic surveys, especially when there was a lot of detail. On the hardware side, another big breakthrough was when Leica introduced the first scanner that had survey grade tilt compensation in it. That was something they called a Leica scan station. That was in 2007, and that was a big plus for registration and georeferencing. It's still a big plus if you look at all the blogs out there. It's a big comfort for surveyors, right? To have tilt compensation makes everything a lot better. Another big breakthrough on the civil infrastructure side was back on the site and topographic surveys. There was a big breakthrough in the office. It was called it was a capability to do what was called virtual surveying. And this is where instead of using a toll station or a GPS unit to do feature coding, or like using a data collector in the field, right? That capability was built into the software, right? So you collect everything in the field, you scan everything in the field, and then you could simply by looking at the point cloud data, you could feature code in the office, right? So you could do in the imagery was so detailed that you could do edge of curb, manhole cover, road stripe, however you wanted to code it, you could just code it in the office, right?
Yeah.
And you essentially had a built-in QC capability because you could see exactly what was there, right? There was no mistake. You wouldn't miscode something, right? Because you could see exactly what was there.
I have just a technical question here. The imagery was RGB. It was color or just
The imagery was not great at that point in time. There was always a frustration in the early days especially with Leica instruments. I mean, here Leica, the name is a camera, right? But the camera that was in the early scanners was good for targeting and some crude visualization. It wasn't great, but there were ways to false coloring of the imagery to be able to look at the views in 3D where you could determine what you were looking at, right? So it wasn't the high resolution color that you see today in today's scanners, like an RT360. It's got the very high. That wasn't available back then, but what was available was good enough for still to be able to do that kind of a feature coding in the office, right? That virtual surveying, right?
so it was just intensity or
You could
the
do no, that
scanner?
you could put true color over it. It was a kind of it was a tedious process. You had to use an external camera to
Okay.
get decent color, and then color you had to map that to the point cloud. You could do it. Wasn't that easy, but some people would do it if they felt that they really needed it. Okay, but it's a good question, right? The real high visualization stuff didn't really come in until much later. Like Faro Focus had pretty good visualization when it came out. And now, the RT360, I mean, a lot of these have just fantastic true color, a lot of the scanning capabilities out there. The next big market to crack open after we did plant first and then civil infrastructure came. The last big one was buildings, right? Just commercial buildings, residential buildings, whatever you want to call it. If you look at the world market for construction, the biggest market is buildings, okay, by far. We knew that in advance. But it was always a challenge for the technology in the early days to have a cost-effective way of using scanning for buildings to do as-builts. And that was a much more price-sensitive market. And the architects did a lot of that themselves. They didn't really want to give it up. There were a lot of barriers to sort of using scanning for capturing buildings other than that, kind of historic buildings, right? But on the building side, that was always the biggest nut to crack, right? On the building market, there were three breakthroughs, right? I'll mention each one of them, then I'll dive into each one. One was on the hardware side, just the advances in hardware to be able to do it much faster and cheaper. Just the price points started coming down, the speed started going up, and that efficiency in the field translated into the lower cost projects, right? So that was a big one. The next big thing that happened in the buildings world was BIM, BIM, Building Information Modeling, right? When BIM first started to be talked about, it was like, oh, this is pretty cool. I mean, building information modeling, the industrial plant market had been doing that for many years. Intelligent 3D models of plants had been around for many years, but that wasn't being done in buildings, right? That's what BIM is, right? And it'd been talked about for a while, and all of a sudden it got really hot in the building construction industry. And it went from almost overnight, this was around the 2010 time frame or so. It went from being nice to talk about to like you had to have it. If you were a contractor, building construction company or design company, architectural design, if you weren't using BIM, you couldn't get the project, right? So BIM is 3D, 3D modeling and laser scanning and 3D modeling fit together like a hand in a glove. Okay, it's a perfect combination. So BIM got hot, and that accelerated the adoption of laser scanning in the market, right? And then the last ones were these, I already mentioned a little bit, but the Google Street View and Matterport's 3D walkthroughs, those are for buildings, right? Those are homes, right? And so I'll dive into them a little bit more. On the hardware side, I said big advances on the hardware side really helped. First big one was when Faro came out with their Focus 3D scanner in 2011. That was about a 50% reduction in the price of the scanner. It was also much smaller, and it was also very simple to use. Okay. And when you start, for surveyors, it wasn't that important. Surveyors are used to, using, expensive instruments, and they're okay with the sophistication of them. But when you start dealing with contractors, it's construction companies, it's a different deal. It has to be cheaper and easier to use. Architects, the same thing. So that was a big one. That started to really hit the price point that was attractive for a lot of in the commercial building world. Then came out the BLK 360. That was introduced in 2016. That was another 50% reduction in price, right? And that one was good, but for smaller spaces. But those big price and performance, price reductions and performance increases, they really played strongly in the building construction world. Okay, that's mostly where those scanners are used. Another big breakthrough for the building world was these walk around scanners like GeoSlam, right? All of a sudden, I mean, those scanners, they're accurate enough for certain building, as-builts, right? Residential as-builts even. You want to modify a residential building. but those things are up to 10 times more productive than a tripod-based scanner. I mean, they're hugely efficient, and they're not very expensive, right? So the introduction of GeoSlam and all the other ones that are these walk around or push around or carry around on your shoulders, there's all these, I just call them walk around scanners. The place where they played the biggest benefits, the market is in the buildings. Okay. They're used for buildings. And so that was a huge turning point. I mentioned the BIM already as being a big deal. And then lastly, these, if you go around looking at new home to buy, you see the listing of the property, and you see a little block that says Street View, and another one says 3D walkthrough, right? Street views, those are the Google Street Views. Those were done with 3D cameras and laser scanners. Okay. Topcon provided all the original mobile laser scanning for those units. And then the Matterport 3D walkthrough, that's cameras, high-end camera and the laser scanning capability, right? And that's used for residential homes. And that was, just for marketing them, not even for engineering construction, just marketing. It's just marketing, right? That's what it is, right? That's a marketing application. So for the buildings market, there were a lot of innovations and breakthroughs over time that just made it almost ubiquitous today. Okay. So those are the big three: the industrial plant market, the civil infrastructure market, and the buildings, right? The big three AEC ones. But those weren't the only markets that had breakthroughs that are interesting for scanning. Okay. There's other ones that are not quite as big, but some of them are pretty big unto themselves, and they're fun to talk about. One is scanning historic properties, right? You're based in Belgium. I don't have to tell you this. So many old buildings, right? In terms of the number of scanners, and I've been away from Leica for a while, but the number of scanners that are sold around the world by country, the largest number was in the United States. Second largest number of scanners that was sold was in Italy. Okay. Because of all these old buildings, right? The most successful customers we had for a long time in Leica were in the UK, right? Because they get these structures that are these old buildings. People want to make improvements to it, but you have to retain the original facade of the building. You have to retain all those. These are old buildings, so they're not perfect, Anyhow, historic buildings are a big deal in scanning. And there were some projects that were done that got very widely publicized in the earliest days. The first one was called, it was done by Stanford University. They had some scanners, and they did a project that was called the Digital Michelangelo Project. Okay. And they went to Italy and they scanned a lot of Michelangelo's most famous works, okay, sculptures, right, including the statue of David in Florence. Okay. And that project received enormous publicity worldwide. It was covered by, the New York Times, all these big newspapers all around the world. It became, and when you're, a little startup company, and all of a sudden you've got projects that are being talked about with scanning, and they're on, magazines, they're on television shows. It was a huge boost for the exposure of the technology. Another big one that was got a lot of exposure was the scanning of the Statue of Liberty in New York. The statue was scanned because there was a concern about terrorism, right? And that it might be a target. And in fact, it was scanned 3 months before 9/11. was literally, and that statue is right across the river from the World Trade Center. It was scanned 3 months right before then. But that scanning of the statue got a huge exposure in the media, in the popular media. There were lots of other ones that were scanned. There was the Cheops Pyramid in Egypt, the Notre Dame Cathedral in Paris, Mount Rushmore in the United States, and all these famous sites that were scanned, or all of a sudden they were getting in the newspapers and on television stations, and there was a big exposure for it. It was like, oh, this is a good idea. A lot of universities, when they first got into scanning, they were out capturing historic sites that were near them. And those are interesting to the public, so they would get a lot of exposure, right? Another huge accelerator for the use of scanning was there was actually a television series that was developed by PBS in the United Public Broadcasting System in the United States and National Geographic worldwide. And the television series was in 2014 and 2015, and there was 6 episodes, and it was called Time Scanners. Okay, Time Scanners. I don't know if you've ever seen them or not. Each episode was a full hour long. And what it did was the show had a world-renowned structural engineer. His name was Steve Burrows. And he was accompanied by a very experienced 3D scanning team from University of Arkansas. And they went to 6 famous heritage sites around the world to use in the promotion of the series was called to use modern technology to help solve old mysteries. Okay, so they scanned sites that included some of King Herod's structures in Jerusalem. They went to Peru and scanned the ruins of Machu Picchu. They went to Jordan and scanned Petra. They scanned the pyramids of Egypt, some of the major ones. They scanned St. Paul's Cathedral in London, and they scanned the Colosseum in Rome. And they made a full-blown television series out of all that. And it was heavy duty on the scanning and the visuals and all that. And that exposure made, it just made so many more people aware of scanning and just brought in that more people into that whole field. It's a big one. Okay. Another industry that got a big boost from a television exposure was the use of scanning for forensics. The scanning, so we always knew that could be used for that. The very first case was the USS Cole. It was a naval ship that got attacked in the Gulf in the Middle East, and they brought in the scanner to scan the damage. Okay, but other than that, around 2005, got an order from the California Highway Patrol for was over $1 million worth of scanners, software and training. It was a huge order, right? And the Highway Patrol would use it to scan crashes and accident scenes that had happened on the highway. And the benefit of scanning is that it would clear the road faster. You capture all the detail fast, clear the road faster, and then you had an accurate record of what was there in case they wanted to investigate the incident. So $1 million order that caught the attention of our local sales representative. Okay, his name was Tony Grissom, and he decided to focus on the forensics market for scanning. Right. The major vendors at the time, ourselves included, weren't really looking at the forensics market much. It was more the other markets I was talking about, plant, civil infrastructure, buildings. But so he went about the task of trying to educate that market about the benefits of scanning. And there were several breakthroughs in there. One was the first time it was used in a case. It was allowed to be used in a case. It had to meet some very rigid criteria to have the data from a scanner be accepted in a court case as evidence. And so there was the first court case for that where it was accepted. That was a very important breakthrough that enabled it to be used in other cases. But there was another interesting one that was also television related. At that time, there was a whole bunch of new television shows that had this we call the CSI effect. They were doing a lot of very sexy computer graphics, right? Instead of just showing a drawing in the courtroom, right? They would show very fancy animations and sexy visuals, and 3D scans just were fit perfect in there, right? I mean, it was a perfect fit. That's what jurors started to expect. Courtrooms started to expect these high-end computer animations, right? Or computer, and visuals. And there was a television series that was starting up. It was by A&E, A&E, right? Television, and it was a true crime series called Crime 360. Okay. Crime 360 fell in love with the scanner and the point cloud visuals and the scanning. All the visuals around it fit great into it. And the scanner, Leica scanner, was the star of that series. That series ran for 2 years. Okay. And scanning. And so what happened was that the crime labs and the forensics specialists, they would watch these shows too. Their families would watch the shows, right? And all of a sudden they're all seeing this scanning thing, and they say, "Well, that looks pretty cool. Let's check it out," right? And there was an explosion of interest in the use of scanning to capture crime scenes. And it turned out that scanning was really a big benefit in capturing crime scenes, getting very accurate. There was even some of those scenes in incidents that where scanning was used. They were featured globally when Princess Diana had the fatal car crash in Paris, right? They brought in a scanner, I think, from a UK service provider. It showed that the tunnel being scanned to try to figure out exactly what happened in there. So all of that public exposure drew a lot of interest in scanning, and scanning has really good, solid benefits in that space. And today, the forensic market is one of the larger markets for scanning, use of scanners.
Yeah. And from my experience, I remember the first time I ever seen a terrestrial laser scanner was in National Geographic, a series that showed the acquisition of point cloud in the United Kingdom of some cultural heritage
It was
places.
St. Paul's Cathedral, right? That's the television series I was referring to. It's called Time Scanners. You can still go get those up. You can still go and buy those. You can get DVDs of those shows. They're still available. And the A&E series on Crime 360, those are still available online. You go look online, you could still see those shows. But that's exactly, that kind of exposure to not just the public, but also, professionals like yourself, people that are in the field. It attracted a tremendous amount of interest in the technology and really accelerated the adoption. So it wasn't just the technical advances. A lot of it was the exposure that the technology was getting in the public eye and for other professionals, because you pay attention to what's going on in the market, right? The last group of industries or segments where laser scanning has become commonplace, I'm going to call it the entertainment industry. Okay, these are movies, feature films, movie sets, video games, TV commercials, television commercials, and television programs. Scanning's used a lot in that space. Okay, and there's an interesting story here. When I very first joined SAR, it was March of 1998. I was like the first marketing guy. I was like, okay, we're ready to try to sell the scanner and software. What I could really use would be a good reference project where the technology had been used, The benefits had been proven, and it would be a good, place just to have a good solid reference. Well, it turned out that a lot of the projects where the scanning had been used, they were like test projects or pilot projects or demo projects. In the plant world, you don't really know if the scanning was any good until they get to construction, right? You see if you have problems or not. Those things take years, right? Well, it turned out there was one project that that Cyrus scanner had been used on that was a completed project. It saved the customer money, saved the customer time. The customer was very happy. Okay, they were very happy, and it was for making used in feature film. Right, wasn't a plant, wasn't in civil infrastructure, wasn't in buildings. It was a movie. The movie was called Starship Troopers. Right, I think you could still see it on, it's out there, still out there. It was a pretty awful movie. Okay, but it was a success for laser scanning. And so the movie, again, Starship Troopers, there's a scene in the movie where the Starship Troopers themselves are in this big cave, right? And the cave was actually a physical cave that had been constructed at the Sony studios, right? It was a big cave. And in the scene, these giant insects were coming into the cave, and they were battling out with the Starship Troopers, and the Starship Troopers were losing the battle. Okay, it was pretty gory. But to make it look realistic, the computer graphics studio, Tippett Studios, they needed an accurate 3D model of the surface of the cave, because when they add these CG creatures into the scene, right? They've got real actors in there, a real cave. They add these creatures in the scene. They need to, put the creature's foot or claw on the ground, right? Or against the wall. The lighting, there's shadows of the creatures. They need to fall along the actual contours to make it look realistic. Okay. And it turns out the human eye is very sensitive to anything that's a little off. You watch some of these things and you can tell when something's off, right? We could tell instantly, right? So to make it look real, they needed a very accurate model of this cave, 3D surface model cave. The studio had contacted a aerial photogrammetry company called Hammond Jensen Waller, HJW, for a quote on the project. And the service provider was going to use close range photogrammetry to do that, create the surface model. And they quoted Tippett Studios was going to be $100,000. This was back in like 1997. $100,000 to do it, and it was going to take, I think, like 3 months before they could deliver this surface model. Tippett said, "Oh, we can't afford that, and that's way too long. From them making a movie here, we can't wait for 3 months." Well, this service company happened to be in the same office complex as Syra in Oakland. But Syra had moved their offices from Marin to Oakland by the Oakland airport. They were in the same complex, and they'd seen a demo of the Cyrax scanner. And they contacted Syra. "Hey, can you help us with this project?" "Yeah, we can do it." Okay, so they took the scanner in, they scanned the cave. Syra helped them a lot with the project. They did it for $40,000, and it was done in 2 weeks. Okay. So this was a real project. Saved the customer a lot of money. It was good. It was for a movie. Okay. It turned out that it was also a much more detailed surface model, and that provided the movie makers, the CG guys, more flexibility in what they could do from making the movie. So that was also another benefit. So it was a real project. I was the marketing guy. I ghost wrote a story about it, a feature article about it that appeared in one of the leading survey magazines. Okay, at the time it was called Professional Surveyor. Now it's called XYHT. And they put a picture, a very gory picture of this from that scene on the front cover of the magazine. Okay. So that got exposure for the technology in that industry. Well, it turns out that in that industry was already familiar with 3D scanning. It turns out if you saw like these, monsters or whatever, computer monsters, computer generated monsters, CGI, computer graphics monsters that were in the movies, in the films, the 3D models of those were taken from like clay figurines, little figurines, and they had small range scanners that could scan a small object. Okay, like Minolta made a small. And so they were already using 3D scanners in movie making. So when the large scale scanner came around, like Cyrax, they got it immediately. I said, "Oh, we get this. Okay, we know how to do this." And in fact, one of the very first successful customers that we had, they had 2 scanners right away, was Panavision. So if you watch a feature film, it's always, filmed in Panavision. They make the cameras for movies. They actually created a service department, a laser scanning services department to scan movie sets. And they scanned lots of them, and they were very successful, right? They were very successful. And the way that all worked out as far as a breakthrough was these professionals that work on movies. Movie is called a project. They do one movie and then they move to another project. So it's a very small number of them, and they, just word of mouth got out about 3D scanning, and it became very popular almost instantly in making movies. Okay, and if you look today, there's so many. There's even a call out at the end of a lot of these movies that have a lot of CG effects. Laser scanning services. There's all these credits at the end of a movie, lots of them, right? There's a call out now for laser scanning services provided by, right? So there's a company out there called Scannables, Scanables. They do tons of these things, right? And they're called out all the time in movies. It's pretty crazy. The Game of Thrones, right? That scanning was used heavily for the city of Dubrovnik, right? To do all these, super cool computer graphics stuff. They use scanning all the time for those things. And word of mouth got it. Along that same line, scanning is used in video games, right? And there, I think the first big use of scanning video games was for golfers, for Golf Channel, right? They'll show the golfers, the professional golfers are at the green, and they'll show the expected travel path from the putt to get to the hole, right? The way they do that is they use a 3D laser scanner to capture the very detailed surface of the green, right? And so they can replicate. I mean, they've also done that. If you want to take a hole from a famous golf course and replicate it on another golf course, that's how they do it. They scan the hole, they scan that area, they get an exact topographic detail of that, and they can use that to make a replica of that hole on another golf course. But for video games, that's the first one. Is you'll see the trajectory. All that is enabled by scanning. Another place where it's used like that to make it realistic is for race car games. So you get in a car, you want to drive a famous track. That track has been scanned in infinite detail. Every little nuance and bump in the track is represented in that game. So you're scanning on a track, and that's the real surface. I mean, it's all virtual, but that's exactly what that track was. Okay. So there, that whole field is just enabled by laser scanning. And again, I think it was once it was used first time, they figured it out. So we got to use this stuff, and they all started using it. Right. So in addition to these kind of industry-specific advances. There was some other general ones that I'll just mention briefly here. A big breakthrough, especially for the surveying world, was when the first scanner that was produced that had everything is all in one unit, right? The controller, power supply, everything was before. In the beginning, you had a separate. The first scanners were all controlled by laptops, okay, and you had a separate power supply, and then you had the scanner. When it was finally integrated into a single unit was the Leica Scan Station C10 in 2010. That was the first one where everything was all together in one unit. And surveyors in particular like that. It was like a total station. It's like, okay, we don't have to carry all this other stuff around. It's all together. And then the next year, Faro Focus 3D scanner was also all integrated in one. You had the controls, everything you needed in the scanner. I talked about the price points. Anything that was enabled a big drop in price points was a big accelerator for adoption. Size, I mean, the BLK 360 is what? Now it's 1 kilogram. It's the size of what I call a tall beer can. The walk around scanners, GeoSlam, a huge advance. I think a real huge one. On the software side, there were a lot of advances in registration, right? In the early days, if time in the office, we would often ask customers, well, how long did you spend in the office to do this project? How much of it did you spend on registration? How much did you spend on creating deliverables? Registration was often half of the time in the office. Sometimes it was 90% of the time. They would spend almost all their time on registration. It was hard, right? So there were a big advance there was the first introduction of cloud-to-cloud registration. That was quite a long time. It was the early 2000s. Another big advance was that you could do registration in the field. The instruments would do it as you walked along. There's a lot of, it's almost an automated process now, but you have to be really careful to make sure you do registration accurately. That's probably the one where surveying skills come in the most handy, is they really understand that process of registration. Another big development breakthrough for the industry was the first industry standard for data format, the E57 data format. Okay, that was when that was adopted, then you could start using any scan data from any scanner and convert it to E57 format and use it in any software. Right. Before then, you had to use only the vendor's registration software or processing software. But the E57 was a big breakthrough. So over time, we had all these advances within the laser scanning community. None of it would have been possible without parallel advances in computing technology. Between the chip speeds, storage capacity, to graphics cards, all the digital imaging technology, the internet stuff. I mean, all of the advances in computing technology were happening in parallel with advances in the scanning technology, both on the hardware side and on the software side and on the sharing side, right? You want to share files and share images and all that. And they were all happening together. And all those advances really helped enable the technology to where it is today, where it's almost ubiquitous. So I know this was a long answer to a question about breakthroughs and advances, but there was a lot. And
Yes.
And it's fun to talk about all, because they're all big deals, and
Yes, it was
amazing.
it was very interesting to listen to you talking about all this turning points and breakthroughs. So it make a full part of our podcast. So I think
Okay.
we will make another part
Okay.
where we talk about the other points.
The other points, right? They're none of the other ones. The other ones are all interesting too, but none of them will take as long to talk about as that one. Because there've
Okay.
been to get to where the technology is today, which is amazing. I never saw it get to where it is today in really the span of 25 years, which is nothing. It's incredible, the progress, both on the technology side and on the exposure side, the adoption side. It's been a fun, fast ride, but still more fun stuff to talk about as well.
Okay, we will do. Thank you
Okay.
so much for your time and for all this information. And we'll see you in the next part
Next
of
time.
our podcast. Thank you so
Okay.
much for your time.
Okay. Sounds great.